Greetings, geometry students. I appreciate you finding time to get your notes taken care of. I anticipate that these will be the notes for Thursday's class, but predicting it that far in advance, keep an eye on the bulletin board on Edmodo for future updates about when these particular notes will be due in class. Okay, today we're talking about reasoning, so copy down the title as well as our objective and our essential question. Our objective for the day was to discover the similarities and differences between inductive and deductive reasoning. Now, the way I'm going to help you get from point A to point Z on this is the student is eventually going to be able to demonstrate the ability to identify the hypotheses and conclusions in provided examples of reasoning. You're probably already familiar with some terms like hypothesis and conclusion from your travels through science class. You're going to find that it has a lot of the same meaning in mathematics. Just might be a little bit more information-based here in geometry than it was scientifically or experiment-based in science. And the essential question, which is something we need to be paying a little bit more attention to as we go through our lessons, your self-reflection question that you have at the end of your studies is, do I understand reasoning, its parts, and its purposes? A lot of you are completely disregarding the essential question, which means you are just copying down notes just to copy down notes, and it is not getting you anywhere, and it's just not going to work out for you. So make sure at the end of everything, ask yourself the essential question. If you cannot answer that yes, you honestly do understand, then you need to spend some time studying rather than just proving you know how to copy notes down onto a piece of paper. As always, anytime you need more time to get something taken care of, press pause and then hit play when you're ready to move on. And here we go. I'll go ahead and apologize in advance. A lot of this is wordy, very information-based today. Several examples to write down, and most of it is sentences. So let's just get to it. Okay, now obviously we're talking about inductive and deductive reasoning. Clearly, humans have the ability to reason. And a lot of you spend a lot of time asking questions about mathematics. When am I ever going to have to use this? What is this ever going to be used for? Well, I do believe that problem-solving skills and basic problem-solving strategies are going to be something that you're going to need for the vast majority of your lives. Now, that may not be finding the area of a parallelogram or solving for x, but a lot of how you go about finding the area of a parallelogram or solving for x deals with problem-solving strategies. That is what mathematics is all about. Okay, so those problem-solving strategies are basically reasoning skills, identifying a situation and figuring out how to proceed through it. Okay. Now, what we do as humans is we observe our surroundings. We come to conclusions, we make statements, about our observations, and obviously many times without knowing all of the facts. Now, there can be a lot of reasons why we may not know all of the facts moving into a situation. Maybe not all the facts are available to us, or another problem is we just get a little bit impatient. A lot of times we do not take the time to gather all of the information before we try to arrive at a conclusion, hence the term jumping to conclusions. Okay, it's just in our nature that we do this. Okay, but anyway, such thinking is called inductive reasoning. When you observe your surroundings, look for patterns or predictabilities about our surroundings, we make statements about the observations that we are making. And again, sometimes that means we jump to conclusions. But anyway, this process of thinking is what is referred to as inductive reasoning. We use inductive reasoning as humans on an almost constant basis moving through our day. Sometimes we're correct with our reasoning, sometimes we're incorrect, but that's how we learn. Okay? Inductive reasoning is making a prediction based upon an observable pattern. Okay? Predictions that are made in this fashion are what we call conjectures. Now, conjectures are statements that are believed to be true. Okay, and that kind of seems like a silly thing to say, but we need to say it. Okay, it doesn't do any good to have a conjecture if there are obviously holes in it or places where we can see that it clearly does not hold true. Okay, if we're making a prediction based upon observable patterns, well, obviously we would not want to be making a false prediction based upon what we are seeing. Okay, so conjectures are believed to be true. Now, here is the thing where with our conjectures, if any situation exists that goes against a conjecture, that should make the entire conjecture false. Okay, and this should be it as a human. When you jump to a conclusion without all of the information, and then some of the information starts to come to light, and you go, oh well, the statement I said obviously is incorrect because now I have this fact in there. Okay, basically what you have is you have something that is going against your conjecture, and that should cause your entire conjecture to basically fall apart. Okay, when such a situation does arise, what you have discovered is what we call a counterexample or a non-example. Okay, those terms are synonyms, and we are expected to be familiar with both of them. Okay, and they mean the same thing. It is a situation or an example that disproves our conjecture. Okay. Now let's take a look at a couple of examples of inductive reasoning. I think you'll probably see how easy this is. Okay, but examples of inductive reasoning. Okay, here is a statement. The sun has risen every day of my life, so the sun will rise tomorrow. Okay, now that seems like a reasonable thing to say. It doesn't sound like we're too far out on a limb, but what we're doing is we are observing a pattern and then making a statement based upon it. Okay, but the bottom line really kind of comes down to this. Do you know for a fact that the sun will rise tomorrow? Now, I'm not splitting hairs and arguing semantics here, saying, oh, the sun doesn't actually rise, the earth actually turns toward the sun, which is standing still. Okay, not arguing that, just talking about the general idea of, it's dark and then the sun suddenly becomes visible, which we call a sunrise. Do you know for a fact that the sun is going to rise tomorrow? Okay, well, no, we don't actually know that. It is possible the sun could go supernova and there may not be any more sunrises. However, based upon the observable pattern of what we know is supposed to happen on a daily basis, okay, that is a reasonable thing to say. So based upon the pattern of it rising every day, we can say, you know what, on all the information that we have, it should rise tomorrow. So what we have is a pretty solid conjecture, a prediction based upon the observable pattern. And unless the sun goes supernova, well, we're not going to find a counterexample to go against that. And unfortunately, if we ever do find a counterexample, we probably won't be needing geometry really anymore. Okay, here's another example. Okay, and this one's always one of the crowd favorites. I do this one every year. When walking home on Tuesday, I saw a dog. Okay, I reached down to pet the dog, and the dog bit me. Next day, walking home, saw the same dog. Since we're not very smart, I reached down, I pet the dog again, it bit me again. Next day, same thing. Okay, well, at some point in time, we're probably going to get smart, and we're going to quit reaching down to pet the dog. Okay, but from a position of inductive reasoning, okay, we would say, all right, so if I see the same dog today, and I reach down to pet that dog, it will bite me. Okay, well, that seems like a very reasonable thing to say. Okay, based upon the observable pattern, walking home, seeing the dog, trying to pet it, dog bites me, happening repetitively, this seems like a reasonable prediction to make. Now, do you know that the dog is going to bite you? Well, no, we don't. Okay, everything about common sense would tell you, yeah, it is. Quit trying to pet the stupid dog. Okay, but you don't actually know that. It is simply a reasonable statement to make based upon the observations that we have available to us. Okay, so this is inductive reasoning, making predictions based upon observable patterns. If we were to reach down to pet that dog today, and the dog did nothing but let us pet it, well, there you have a counterexample, and that would disprove our conjecture. Okay, now conjectures are usually presented in what's referred to as conditional format. And conditional format is basically this generic structure: if P, then Q. Now, P and Q are certain pieces of information, actually very important parts of sentences. Okay, they are the information that is going on in the sentence. The P part is called the hypothesis. Okay, and the hypothesis is the information that is associated with if, as you can see there in the conditional format. No great secret there. Okay, but the hypothesis is the part of the situation that is being observed. Okay, so that would be the sun rising every day of your life. That would be, I'm walking home and I see the dog and I reach down to pet it. Okay, that is this part of the situation that can be observed based upon whatever it is that is going on. The Q part of the conditional format is what we call the conclusion. Okay, obviously it is the information that is associated with the then part of the conditional form. And the conclusion is the statement or prediction that is being made based upon the observation. Okay, so going back to the previous slide, okay, conclusions would be, well, the sun will rise tomorrow. Okay, we saw it rising every day, so we make the prediction, the conclusion is it will rise tomorrow. Or the conclusion is, you reach down, you pet that dog, it is going to bite you again. That's the conclusion, the statement or prediction that is being made based upon whatever your observation was. Okay, so for example, if we are in geometry class, then today is a school day. Okay, now don't overanalyze this thing. I realize that right now you could pretty much make the argument that you are in geometry class. You are listening to a geometry lesson. You are getting geometry notes. So technically you're in geometry class. Okay, I understand. But right now, let's just say if your body is sitting in a desk in room 222 at the school, then you are in geometry class. That would mean that today is a school day. Okay, let's take a look at that. Okay, the statement we are in geometry class is the hypothesis part of the conditional form. Okay, it is the observation that is being made. Okay, looking around, seeing that you are in the classroom, seeing that you are in those uncomfortable desks, okay, being bored doing geometry, that is the observation. Today is a school day would be the conclusion that could be stated based upon the observation. Okay, nobody told us that today is a school day is true, but based upon what we know about being in the classroom, sitting in those desks, doing geometry, it has to be a factual statement. Okay, so we don't have, Saturday school where you're at school in room 222 doing geometry. Okay, so there's not a situation or an instance that we know of where being in that room and doing that work, sitting in those desks, okay, that has to be a school day. Okay, so hopefully you can see the difference between what a hypothesis is and a conclusion is. Okay, now one thing that you cannot fall into the trap of is nobody said that the hypothesis is always the first part of the sentence or the conclusion is the second part of the sentence. As you well know, the English language can be rearranged and reworded in a lot of different ways, which is what makes English such a difficult language for people to master if it is their second language that they are learning how to speak. Okay, because there's a lot of different ways to say the same thing. So for example, here is a statement that basically is a synonym to what was said just a moment ago. Today is a school day if we are in geometry class. The sentence is basically completely scrambled up, yet it carries exactly the same meaning. Okay, but decoding it as far as conditional format and hypotheses and conclusions, okay, we are in geometry class, is still the hypothesis because it is still the observation that is being made. And one of the things you can watch out for is that the hypothesis still carries the if part of the statement. It is what is being said. Today is a school day is still the conclusion, since it is still the statement that is being made about the observation. Notice that the word then no longer appears in the sentence. Okay, you can't always just watch out for if and watch out for then. It's not always that simple. Okay, so you have to read the information and decide what part is the observation, what is the thing that can be seen, or what is the prediction that is being made, okay, and then what is the conclusion that is being stated about that observation or prediction. Okay. As we said, counterexamples work to disprove conjectures. So if one does exist, then that would mean that our conjecture is false. Okay, so let's say if we can find any case where a conjecture is false, then it is entirely false. So for example, here's a statement: if today is a weekday, then it is a school day. Well, if we can find any situation that goes against this, then we would be forced to abandon this entirely. Okay, so do situations exist that go against that? If today is a weekday, then it is a school day. Well, yeah, I think it'd be pretty easy to find examples where that is not true. Holidays, teacher work days, summer vacation days. These are all instances where it is Monday, Tuesday, Wednesday, Thursday, or Friday, yet we are not actually required to be at school. Okay, since we can find any situation that goes against it, okay, that would be a counterexample, and it would cause us to discard the conjecture. That example statement, if today is a weekday, then it is a school day, we would throw that entire thing out because it has counterexamples. Okay, now this one won't take nearly as long, so if you're fretting about the length of the video, don't get too mad about it here. Okay, we've spent all that time talking about inductive reasoning. Deductive reasoning is not as difficult to understand. It's pretty cut and dried. Deductive reasoning is basically based upon facts. So what we get is factual statements based upon other factual statements. Now this one seems a little strange when you kind of see it unfold, because it seems to not, the end of the problem doesn't seem to have a whole lot to do with the beginning of the problem, and it's not necessarily a problem, it's more of a line of reasoning, a line of thinking. Okay, so here's an example, and this is a fact. Okay, you are in Mr. Hill's geometry class. Okay, if you weren't, you'd have no reason to be listening to this video, complaining to yourself about how long it is. Okay, this is a factual statement. Okay, you are in my geometry class. Okay, now by deductive reasoning, what we could do is we can make other statements that may be completely unrelated to the first statement that was made, yet it is information from the first statement that allows us to make the second statement. And then a second statement might be, okay, let me think about what I know. Hill teaches at Odessa High School. Okay, so if that's the case, then you, listening to this video, you are a Bronco. Okay, now that's somewhat related to the original statement, but really does not have anything to do with the original statement. We are making factual comments based upon other facts that were available to us. Okay, and this can continue on forever. Okay, there you are. You're sitting there. You're in my class. Okay, you're in my geometry class, and you're sitting there listening to this video, wondering how long it's going to be, saying this is stupid, I don't want to have to do this, and there you are taking notes. Since you are taking notes, okay, then based upon what we know about being in my geometry class and taking notes, we can state you are currently writing in the Cornell format. And again, like, it seems very disconnected and doesn't seem like anything has anything to do with anything else. But again, it's facts based upon other facts. If you've ever heard the little saying or adage, whatever you want to call it, 6 degrees of separation, one fact leads to another, the second fact leads to a third, the third leads to a fourth, and so on. And in the end, you end up with two statements that are completely unrelated, but they are facts based upon other facts. That's what deductive reasoning does. Okay, so none of these things had anything to do with the original statement, but they are facts based upon what we knew about the original statement. That is the concept of deductive reasoning. Okay, so that is it. What we need to do now is you need to come up with a summary. Pardon me, that shouldn't be on there. That's not a summary. You need to write your own summary. Okay, summary is a couple of statements that kind of tie all the information together. If you have any questions that you need to answer or you need to have me answer in tutorial times, okay, jot them down there and keep the essential question in the back of your mind. Do you understand the different types of reasoning, the parts of the reasoning, and the purposes of the reasoning? Okay, that's the end game. When we get to the end of the lesson, you need to have an answer for that essential question, and if it's not a good answer, then you need to do something about it so that you can understand. Okay, I apologize for the length of the notes. I typically don't like them to run this long, but I do appreciate you getting them taken care of, and I'll see you in class.